Hello, pre-calculus. Today we are going to be starting section 4.4, graphing sine and cosine, and today's going to be the intro. So we need to look at the generalized equations for sine and cosine. Just like any function, there's a generalized equation, and we're going to have one for sine and one for cosine, and they are super similar, which is kind of nice. Okay, so they are going to be, for sine, y equals a times sine parentheses bx plus c and then plus d. And cosine is going to be exactly the same, but instead of sine, it's cosine. Okay. So question is, how does each letter affect the function for sine and cosine? So A, you might be thinking vertical dilation, and you're not wrong. But sine and cosine are unique functions that have their own kind of vocab set. So A is going to also be the amplitude. So the amplitude, technically, it's the absolute value of A. So if it's negative, that's going to be its own thing, which we'll talk about in just 1 second. So the amplitude, the absolute value of A, if there's just a number here, it's the vertical distance from the sinusoidal axis and if it's negative, A is less than 0, the negative part is a reflection over the x-axis. So A itself is going to affect the amplitude, and that's the distance from the sinusoidal axis, which, if you don't know what that means yet, makes sense because we haven't done it. We'll talk about that soon. B is going to help us determine the period. Oops, wrong. I don't know how dark this is. It's not too bad, you can still kind of see it. So B is going to help us determine the period. And the formula for period is 2 pi divided by B. And I'm going to go over a visual of like what period is and what amplitude is as well. Okay, today we're gonna just ignore the bx plus c situation. We're just gonna focus on A, B, and D, and then we'll talk about this another day. D is going to be your axis, the sinusoidal axis. It's also known as the midline. Oops. So D is your axis. And the equation will always be y equals d. Okay. All right. So let's do a little picture. So the sine and cosine are both curves. So pretend this is my curve. The axis, you could also think of it as midline, is going perfectly in between the max and the min. So it's like a dashed line, and it's what this is like revolving around. Okay. The distance between the patterns is going to be the period. So from like max to max is a period. So it starts up and then it starts to repeat again. So one of those is a period, and the amplitude is going to be this distance here. So the amplitude is the distance between the sinusoidal axis, the midline, and the max, or the min. So these have the same distance. Okay, so when graphing, because that's what we're going to do. When you're graphing, you want to first calculate the period. You want to find your critical point spacing. To do that, it's going to be whatever your period is, divided by 4. And when I say critical points, I mean you need to be plotting a max and then a point at your minimum in the axis. I guess I should have said max, axis, min. We'll show you that in a second. You want to label your starting point. And you want to graph at least 2 cycles. Make sure you read the problem. Alright, so let's show you what the graph of sine and cosine look like. Okay, so we're just going to start with the parents because this is where everything kind of stems from. So sine of x. Okay, so your axis, and I guess I mean like make a list of all of these things. So you want to know what your axis is. So that's going to be y equals 0 because there is nothing being added or subtracted. You want to know what your amplitude is to help plot your key points. Our amplitude is 1. So that's the distance between your midline and your max. We want to know what our period is. And this is all going to come from the unit circle, which is why we taught that to you first. So a period is how many times it's going, like it's one trip around the unit circle. So the period is 2 pi over b, which is just going to be 2 pi for the parent. And so your scale, your critical points, is just going to be 2 pi divided by 4, which is pi over 2. Okay, so I'm going to make my coordinate plane. We're going to go up to 1 because that's how high you go in the unit circle. And I'm just going to leave extra space. And down to -1. And then I'm going to have pi over 2, right? 2 pi over 2, just pi, 3 pi over 2, and 4 pi over 2. And so that'll be one cycle, one period. And then I'm going to have us graph a second period with negative values. So negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay. And if you know your unit circle, graphing it will be easy because you're just going to substitute in these values. So what's sine of 0? Sine of 0 is 0, and that's going to be our starting point. What's sine of pi over 2? It's 1. Sine of pi, 0. Sine of 3 pi over 2 is negative 1 on the unit circle. Sine of 2 pi, 0. Sine of negative pi over 2, negative 1 because we're going backwards on the unit circle. Negative pi is 0. 3 pi over 2 is 1. 2 pi, 0. So it's going to continue this pattern. So you're going to want to put arrows. Okay. And then we should label our axis, which because it's right here, I'm just going to add an arrow and pretend that we traced it. But if it wasn't at 0, if it went up or down, we want to make sure we draw that in. Now cosine is super similar. Right? The axis, the parent is also y equals 0. The amplitude for the parent is also 1. The period is 2 pi. And the scale, I'm not going to show the work, but it's again pi over 2. Alrighty. So now you're just gonna graph this the same way you did sine, but using our cosine values of the unit circle. So our first point is going to be at 0. And what's cosine of 0? So that's x on the unit circle, and x is 1 at 0. At pi over 2, so x is 1 at, yeah, okay, so cosine of 0 is 1. Cosine of pi over 2, 0. Cosine of pi, negative 1. Negative pi over 2, 0. You'll notice it follows this pattern. Max, axis, min, axis, max, axis, min, and it will infinitely do that. Now because our graph is going to start and end at a max, we need to make sure we show that this is going to continue. We don't want to come from up here, so we want to do an initial curve and then get into it. And then again, make sure you graph your axis, y equals 0. Now it's cosine.